This video goes over question 10 of the chain rule assignment. Here they use the derivative operator dt. So the derivative operator looks like this. If we had d over dx of x squared, our derivative would be 2x. I found this confusing, so I'm going to rewrite this in function notation. F at t equals 4 times parentheses t squared plus 7t to the negative third. Then I'm going to write my version of the chain rule. If y equals f at another function u, so this is a composite function, y prime is the derivative of the whole function with respect to u times the derivative of the inside. So here the inside function, inside to the power of negative 3, is t squared plus 7t. So I'm going to write out u equals t squared plus 7t. Then u prime, or u prime of t, but using the variable in the function notation just takes up too much time and space. So the derivative of u is 2t plus 7. So then putting the whole function together, f prime at t is the 4, which is a constant multiple. And I'm going to use the power rule on the parentheses. So times negative 3 times parentheses t squared plus 7t. Then I reduce this exponent by 1, so that's negative 4. And then I have to multiply by the derivative of the inside. So I made this little table here so I know what u is and I know what u prime is. So times 2t plus 7. So to clean this up a little bit, we're going to go ahead and simplify this to negative 12 times 2t plus 7 times t squared plus 7t to the negative fourth. Perfectly good answer. The book should take that. But what the calculator will come up with, and what most people would simplify to, is negative 12 times parentheses 2t plus 7, close the parentheses, and then move this across the fraction bar and make this exponent positive. T squared plus 7t to the positive fourth. So we'll put this in. So do a fraction. Negative 12 times parenthesis 2t plus 7, close that parenthesis, go down to the denominator, parenthesis t squared plus 7t, close that parenthesis, and raise that to the power of positive 4. We'll check the answer. Nice work. And we could also do that in the calculator. So I'm going to actually show a skill where I can define the function in the calculator page. So I'm going to go f parentheses at t. So that lets me use another variable other than x. Control palette of math, and I see this blue colon equals. That's calculator language for f at t is defined as. So we'll put in 4, then times parenthesis t squared plus 7t, get out of the parenthesis, then to the negative 3 power. So I've defined that function. It's now part of my variable list. So if I put in f at t, I should get back out, oh, the calculator actually did a little bit different. They moved this to the denominator, made the exponent positive 3, and they factored out a t, cubed that, and moved it outside of the parentheses. So the calculator simplifies things with a little bit different rules. Now I'm going to take the derivative, shift minus, my variable is t, tab f at t, and we get essentially the same thing, but again they factored out a t raised it to the fourth power. If we're not sure about that, can we make sure that these things equal? So our answer was a fraction negative 12 parenthesis 2t plus 7 down to the denominator parenthesis t squared plus 7t all to the fourth power. And it doesn't say, oh, wrong, needed to be the fourth power. To the fourth power. So that should say true. So those are equivalent. And we did get the answer right. That concludes this video.